In this video, we're going to solve some velocity and speed problems. And the examples just get a little bit harder each time, so we're going to try them out. So this one says a bike travels at a constant speed of 4 meters per second for 5 seconds. How far did it go? The first thing we want to do is we want to underline what they've given us. This is 4 meters per second, and since it's in the units of meters per second, we know it's a velocity. This is 5 seconds. Since the units are seconds, it's a time. And then how far, that's a distance. Like how far did you run? Okay? So, let's go ahead. Let's write the things that we were given. Eventually, you guys are going to have a lot of formulas to kind of deal with. And so it's really nice to kind of write what you know, because you can look at what you know and then you can look at your formula sheet, and based on what you know and then what you want, you can kind of figure out what type of formula you're going to use. But right now we only have one, so it's not such a big deal. But anyway, I put my velocity and my time, and then my distance is in meters. It's up here in meters, so I'm just going to leave it here in meters. Okay? And then we have this formula. V equals D over T. Now, I might have shown you in another video. I might not have. I don't remember. So I'm going to go ahead and show you this really cool thing that I didn't even learn until I started teaching. I call it the triangle, and you can basically put any formula that has like 3 things like this in the triangle, and then you don't have to do algebra to rearrange the equation, which is nice because it saves you a couple steps. So what I did here is V is all the way on the left in my problem, and so I'm putting V all the way to the left in my triangle. D is on top on the right on my triangle, or in my formula, so I'm going to put it on the top right here. And then time is on the bottom, so I'm going to put it on the bottom. So you can kind of see V equals D over T. So if D is the thing that you want, you kind of shade that out, and then you know that D equals V times T. So it's pretty handy. So let's see what we've got. We've got this little formula. D equals V times T. And I'm going to use my little train track thing that we talked about when we did conversions, and I'll show you why. I'm going to put 4 meters on the top, and I'm going to put seconds on the bottom. Okay, so this is 4 meters per second. I'm going to draw my little line. And now I want to do my velocity times my time, or multiply by my time. So I'm going to put 5 seconds here. Now the reason I did this, you can just do the multiplication. I know that you can do that. It's just the same as doing this. Right? These are the same thing. But the reason I like doing it this way is because you can see that the seconds cross out. So, and you're left with units of meters. So it's just kind of like another way to check and make sure that your answer is right and that you're doing it the right way. So we have 4 times 5, and that is 20. So we have 20 meters. So our bike went 20 meters. Now remember, you have to put units. If you don't put units, I automatically assume elephants. And a bike traveling at 20 elephants is a little longer than a bike traveling 20 meters. So just make sure you put units on your answers. If not, I have to mark it wrong. And I hate that, but it's just the way it is. Otherwise, 20, I don't know what you're talking about. 20, whatever. So that was an easy one.